This video will introduce Squirrel, a system for continuous query processing, specifically targets at queries with multi-way foreign key joins over an acyclic schema. The formal definition of continuous query processing is as followed. Given a database instance, a query, a data structure over the database instance, and some updates, the system need to maintain the data structure under the updates. Depending on the application, there are two output modes. The first one is delta enumeration, where the system will output all differences before and after the update. The second one is full enumeration, where the system will output the query result in constant delay. For a foreign key acyclic join query, the updates can be made to any relation in an arbitrary fashion. In a recent SIGMAD paper, the authors show the cost for handling the updates will depend on lambda, which is the inclusiveness of the update sequence. Although the inclusiveness of an update sequence can be high in the worst case, for most real-world update sequences like sliding window model, the inclusiveness is constant. Squirrel uses the newly developed algorithms to achieve the lambda update time. In addition, Squirrel has the following distinctive features compared with other continuous query processing systems. First, Squirrel considers a multi-way join as one operator. Traditional approaches for continuous query processing would decompose a multi-way join into multiple two-way joins, and materialize the intermediate join results. The figure shows the Flink execution plan for a three-way join query by using first-order incremental view maintenance algorithm. As you can see, the algorithm will maintain the join result between line item relation and orders relation. However, Squirrel does not need to materialize the intermediate join results, which significantly improves both time and memory consumption. The holistic processing of multi-way joins also leads to better parallelism. First, as all records are hash partitioned by the join key and keys are independent, the records do not need to replicate it. Furthermore, the index structures for different relations are independent as no backward communication exists. These structures can be maintained simultaneously. Thus, Squirrel can easily scale to very high volumes of updates. Although the internal algorithm of Squirrel can be applied to different data processing engines or databases, we built Squirrel on top of Flink. When the user registers a query, Squirrel compiles the query plan into Flink code. This modular design allows us to inherit all the benefits of Flink, such as fault tolerance and elasticity. It is also easy to integrate Squirrel into the broader Flink ecosystem. Next, we will show the Squirrel system. On the web UI, the first component is the query input component. Users can submit SQL query to the system, which will then parse the queries into a JSON file. The JSON file contains the Squirrel execute plan for the query, and the experienced user can also submit a JSON file directly. Squirrel also integrates several SQL query templates. After submitting the query, the code generator will start working. The GUI will receive and display the execution log as well as query informations. Here you can see the interpretation of the query and the generated query plan. When the Flink codes are generated, the system will pack them into a jar and submit it to a Flink cluster for execution. While the input stream being processed in the Flink cluster, the system will continuously receive delta query result and display the query result in both table view and dynamic figures. The demo audiences can also pause the incoming stream to view the query results if desired. In the setting page, users can specify system parameters, such as specifying Flink cluster, or specifying input and output sources. Like Flink, Squirrel system can support file, socket or Kafka as the source. With this demonstration, we invite the audience to explore the full potential of Squirrel, including multi-way joins as one operator, creation of join plans based on the acyclic schema, and ultimately the hassle-free SQL-style user interface. We hope you will enjoy our demonstration.